webinar. Hi, everyone. Hello, how are you? My name is Tepositole, and I'm the project coordinator at RISE International. I'm with my co-host, Reds. Reds, hello.
Hi everyone, my name is Recipile Ramuk and I'm the Design and Media Assistant at RISE, and I'll be co-hosting this webinar with Teddy. Thank you very much, Teddy. Over to you.
Thank you. Thank you so much, Reds. Now, for those of you who are joining us for the first time, RISE is a non-profit social enterprise that operates in Lesotho. We are a landlocked country in South Africa. We focus on economic development through job creation, skills development, and entrepreneurship, specifically in the built environment, through a fellowship program called InLoco. The fellowship is a design, build, and entrepreneurship program for graduates who have studied architecture, construction management, civil and electrical engineering, plumbing and carpentry, among other disciplines. The fellows get a hands-on learning experience and at the same time solving problems in the infrastructure. We turn job seekers into job creators by helping them start their own businesses and taking them through a 3-year incubation program where we connect the fellows with mentors, co-working space, tools, and clients, among other resources. Thank you very much, ladies and gentlemen, for joining us. Please remember to leave your comments or questions in the comment box right here on Zoom. And if you're watching from Facebook, please post your questions or comments in the comment section. Now, for today's webinar, we will be discussing how to design energy efficient houses. We have a very special guest who will be guiding us on this topic for today. Her name is Lulu Yang. Now, Lulu is a trained architect, designer, and educator. She has extensive experience practicing various architectural projects with different studios such as Foster Partners, Gensler, Populous, etc. In the United Kingdom, as well as the USA, Singapore, and China. She has also devoted part of experience to the workplace evolution with real estate companies such as WeWork. She is a tutor and guest critic at Beck Studio in Milan and at the University of Cincinnati, utilizing these platforms to spread architectural education. Her passion towards indigenous architecture has led her to continue her second master degree on design for development in the global south at Politecnico di Milano. And she has continued her experience with RISE for sustainable materials and passive housing research. Welcome, Lulu.
Thank you so much. Thank you, Teddy. And hi, everybody. Welcome to this session and thanks for attending. So I will begin with the presentation, and today is basically a high-level discussion on how to design energy-efficient houses. So to begin with, I want to discuss what is actually housing. There are 3 basic functions of a house. A house is practically a shelter that protects it from sun and rain, protects it from ground humidity, and also protect it from wind and cold. And then there are 3 fundamental elements that composes a house, which are walls, roof, as well as floor. And obviously where those components meet are the weak points. And then with that, we will discuss later in this session. So what does it mean when we say using environment to improve houses? It's practically 3 things. The first one is to design responded to a particular climate. The second is to using compact form and indigenous material. And the third one is to use with passive design strategies. So the second thing I want to touch on is very important in the background, which is climate. Why do we want to discuss climate? Well, it is very important to know as an architect, as a designer, as a builder, where exactly are you placing your house? So based on the classification system globally, there are 5 main climate groups. Tropical, B is dry, C temperate, D continental, and E polar. In the case of Lesotho, for example, is dominated by monsoon-influenced temperature oceanic climate, as well as a small component of monsoon-influenced humid the tropical climate and the subtropical climate. What does it mean in the case of mean temperature and the precipitation? Based on the data from World Bank, so we can summarize from the graph that the highest mean temperature is in January, accompanied with the highest precipitation in January, meaning that the temperature, when the temperature is high, it's actually raining and wet. And the lowest temperature is around June, and the lowest precipitation is in July. Another important factor about the climate is wind. Where does the wind come from? In the case of Lesotho, again, the dominant wind direction is east-northeast as well as the west. And the secondary dominant wind direction is east, west, and west and northwest. So there are some important sources for climate information, and it's important to gather more information and achieve an average understanding of what is actually an accurate data in its location. So then let's talk about active and passive. What does it actually mean when we talk about active and passive design? Practically, passive design is utilizing building itself through insulation, air tightness, natural light, solar gain, natural ventilation to achieve indoor comfort. Whereas the same result is achieved through, for example, renewable energies, MEP systems, energy-saving gadgets, and sophisticated controls within the active strategies. So for that, let's begin to talk about the principles in passive housing design. In general, there are 7, and we will go through each one of them later. The 7 principles are orientation for solar gain, or no overheating, insulation, thermal bridge free, airtight, natural ventilation, and compactness. The first is orientation. The same way that it's important to know where the house is located in the world, it's also very, very important to understand where does the house face on the specific site, to understand where does the sun come from. So for example, in the case of Northern Hemisphere, the sun generally comes from the south. So it's important to face the long facade towards the south, and in order to best utilize the summer sun as well as the winter sun. And obviously the case is reversed in the Southern Hemisphere. As mentioned before, in the Northern Hemisphere, the best orientation is facing south with 30 degrees east or west rotation. One case study that best represents this is one private house in Northern Italy. If we take a look at the plan, it's facing directly towards the south with a large glazing panel on the south facade with a living room area towards the south to maximize the penetration of direct sunlight during the winter and also minimize the summer overheating by the taping of the roof. Also on the east and west facade, you can see the strategic cuts of the openings that in order to maximize the solar penetration. The second strategy is solar gain. In the same vein, for example, in the Northern Hemisphere, we need to have a south-facing facade with a large area of glazing and position main living areas on the south side, and also select indoor floor and wall materials that can store and release heat later on. Back to the same example, we can see that on the north facade, there is a large glazing with living areas that really maximize the solar gain within the room. Strategy number 3 is no overheating. So This strategy is essentially to design with the sun angle. How do we really understand the low sun angle happens in spring, autumn, and winter, and then the high sun angle is happening in the summer. To prevent too much of solar gain, and particularly in the summer period. In this diagram, for example, we can see the three main features to achieve the same result. Through the balcony, a roof overhang, a shading panel that prevents the summer sun from entering the house to exceed the desired solar gain, because it will then add pressure for the cooling. In here, it's important to note that the building physical features are much more effective in order to achieve this control rather than just using blinds or curtains, because it doesn't involve any human intervention to turn on and turn off. In this case study, for example, by Snøhetta, a private house in Norway, they have placed a large fence to shade the house on the upper story windows. And back to the previous example of the house in Italy, as you can see, the roof tapers in to really create an angle that prevents a high sun angle from entering in the house in the summer. So principle number 4 is insulation. Over here, we may get a little bit technical, but it's not really difficult because we have to touch on two basic values. One is the R value and the other one is the U value. R value practically means is a measure of material resistance. So it means that the higher the R value, the more thermal resistant it is, such as this picture. And then U value is essentially the reverse of the R value, and it measures how much heat is lost through a given thickness of a particular material. So in summary, better insulation property would have a high R value and a low U value. In this graph, is a comparison between the German legally prescribed standard for new construction as well as passive housing standards. You can see that the envelope thickness is significantly thicker in the passive housing standard. And the value over here are indicating the U value. As we mentioned before, the low U value are the better insulation properties. So you can see with the thickness, the insulation property increased in the passive housing. The wall buildup. So there are many off-the-shelf products that provide sufficient insulation properties. However, in the passive design strategies, what I want to stress is that there are many materials, indigenous materials, that using the thermal math to achieve quite a reputable insulation performance, such as in this picture, the rammed earth, stone building, wood, etc. This is one example that we showed before, the private house in Norway. You can see here on the north side, they have placed a large stone wall that stabilizes the thermal changes. So this selection of material is not only really utilizing thermal characteristics and embodied energy, but also its ability to contribute to a good indoor climate, air quality, as well as aesthetic qualities. The same way on east and north facade exterior wall, in this small courtyard, they were using wood log that really achieving the same sort of thermal result. Going into a more local case study, this is Pac Moby's house in Lesotho. Pax is not an architect or builder. He's actually a farmer, but he has extreme passion towards indigenous landscape, architecture, as well as materials. So he started to design and build his own house almost completely just using local materials such as mud, clay, cow dung, sand cob, and thatch. His wall, for example, are combined with only 3 materials and using the methodology of wobble and dell. On the interior layer is using the combination of clay and sand cob. On the exterior layer is using clay and cow dung. For the roof, insulation material is a local thatch called the TIFA, which has 0 cost and really, really good insulation property. The framing is a local tree and timber over a stone stem wall. Principle number 5 is thermal bridge free. So thermal bridge, also called cold bridge, is actually a physical path through the structure where heat can escape. So normally it happens where there's a physical connection through the structure that allows a path for heat and transfer from the warm inside to the cold outside. How do you prevent it? Essentially is to break it. For example, in the picture on the left, there is a concrete floor that continues from inside to the outside balcony, but the heat loses with the concrete slab from indoor hot environment to the outdoor cold environment. Whereas if you simply just break this connection with different material and construction method, you would easily prevent the thermal bridge effect. Principle number 6 is airtight and ventilation. So as we mentioned before, airtight envelope act as a physical barrier to prevent the air movement in order to minimize the heat loss. But in the meantime, it's also very important to create openings to allow fresh air to go in. So we have to strategically placing the window that would allow passive ventilation system to function. Warm air is lighter than cold air. So to placing the openings at a proper location would extracting warm stale air outside of the building and intake cool fresh air to the inside. Last component is compactness. So a building that is simply designed, it means doesn't have extraneous parts through which heat can be lost or having potential thermal bridge. We can take many examples from indigenous typologies, such as the Basuto hut is a very compact, simple form. And obviously Pax house is inspired with this form. And also the example that we showed before from a private house in Italy using a compact form. So to conclude, what are the takeaways of the passive housing strategies? It's really not that difficult to achieve because what you all have to do is a little bit more research, planning, and sourcing for the materials. As a result, it would not only saving cost and energy, it will be more sustainable, but also can be very attractive and with many local characteristics. So with that, I conclude my presentation and welcome to any questions if you have. Thank you.
Thank you very much, Lulu. I'll be taking over for the question sessions, and I want to ask everyone that's on the webinar and the Zoom part to ask questions and some in the chat box. And if you're watching via Facebook, you can also do that. We'll be noting them down and asking Lulu as we go on. But my first question, as we wait for questions coming from you guys, is that Lulu, you talked about passive and active design strategies. Could you, you know, give a, a bit of a background on active one and distinguish the two, and why you perhaps support passive solutions more than active ones? Yeah.
Yeah, sure, Red. Thanks for the question. So for me, besides that, I am a fan of indigenous architecture. So I really believe that the indigenous typology as well as the material can help so much to create a more sustainable built environment. I think is much more cost effective and then has long sustaining beauty in a sense. And then this is supported with many research as well. So to me, maybe personally, I'm just a huge fan of natural and passive design. I think obviously in terms of the active design, it uses a lot of the fossil fuel and it's limited resources and is not sustainable. So I think there are much more potentials towards resources that we have to do more research and utilize on.
Okay, okay. Okay, now moving into, the principles. Here in Lesotho, we have, very, very contrasting climate or weather. We have very warm and rainy summer seasons, and then we have very cold and snowing winter seasons. So how would one consider those principles for maximum thermal comfort? I'm just, taking on from the last question and from the last answer that you just gave.
Yeah, so for example, it's very important to strategically placing ventilation because as I showed the climate information before that, whenever the weather is very hot and it also rains a lot, meaning that the indoor climate, if it's completely sealed, airtight without proper ventilation, it would cause a lot of molding. So, but, with where you place the window, you need to study and look at where the wind direction is in order to use the natural passive ventilation to allow warm air to go out and then cool air to go in. And the other thing would be material selections that you have to select, I would say, more indigenous materials, and then perhaps with the form that are similar to Basuto hunt that would allow natural drainage to happen.
Okay, I like that you went towards the indigenous material, and I want us to discuss this because here in Lesotho, I want to say we don't see the value of that, and then people don't um see the kind of material as something aesthetically pleasing, or like do something contemporary. So I mean, you have just talked about its thermal qualities and how it can benefit people. But now, how do you change people's mindset in terms of making them realize that you can use this? And then, I like the project where the stones were used, which is a thermal wall, but it improves the air quality and the thermal in there. But in terms of mindset, what would you advise people?
Um, I think in general, my personal opinion, I think in general, people doesn't know what they don't know, in the sense that if they haven't seen many examples, they don't know how to best utilizing indigenous material. for example, if you just tell a person who never seen Ram, the earth being built in a different way, in a contemporary way, you would probably think of a mud house or mud hut. But in reality, there are so many research and built examples that are showing very good design strategies towards rammed house design, rammed earth design. So I think it's very important, first as an architect, to use more of indigenous material as well as a best design sense to design a building locally for people to see it in person, to be present. And then knowing that, oh, actually, what is that material? That material is something that we always have, but it could be actually using this way, and then it looks amazing. So I think in general, more references, more local presence of a well-designed indigenous material buildings would definitely help with this situation with time, obviously.
Okay. Yeah. Okay. Thank you very much for that answer. Teddy, are there any questions from the participants on the webinar, or can I continue?
No, they haven't. There's no questions yet. There's no questions yet. Just like to remind everyone that's joining us right now to leave your questions or comments in the comment section. If you're watching right now, if you're joining us on Zoom, and if you're watching from Facebook, go ahead and leave those comments or questions in the comment section over there. All right, over to you, Reds.
Okay. So, Lulu, I think, globally, part of the reason why in architecture we're going towards passive design or sustainable ways is because of the high energy consumption in our buildings. So, uh, is focusing only on energy efficiency enhancement of buildings enough to reduce the building sector's increase in energy demand?
No, but it will be very effective way. I think, for example, in one of the examples that I showed, the house in Norway is a net zero housing, meaning that not only they were using passive housing strategies, but they were also using renewable energies in company to achieve the best sustainable result. So I think strategy number one would be using passive housing design strategies to best utilize, for example, creating a concealed building envelope, ventilation, maximum solar gain, and minimize the solar loss, heat loss. The second principle would be minimize the amount of fossil fuel components. And then third one is to add on new technologies such as, obviously solar panel and other gadgets that would maximize and to store and release the energies that we obtain through the materials naturally. So I think definitely would be a combination of those. Additionally, I would think in general, more research has to be done to discover more natural materials that actually, has this component and then would help us in different climate zones to obtain the same, building result.
Okay. So how would you say is, the best way or the most effective way to enhance people's awareness towards energy consumptions in their buildings and more sustainable ways of passive design principles when they deal with architecture?
As if I'm a general audience, like people who wants to build a house.
Yeah.
I think it goes back to the example that the answer I gave before is more through living examples. So for example, there is a friend of mine that has an indigenous house, and then I go in and I see this amazing, beautiful housing design, but also using zero active energy,
Yeah.
but achieving really, really good indoor quality. I think locally also more, also media would help, I would say.
Oh, media. Yeah.
Yeah.
Okay. We have a question from Paul Luana from Facebook. He's saying here in Lesotho, in Murija, there's a Lexa church, Lesotho here, and it has a thick mud brick wall and a thatch insulation inside the wooden ceiling. And can that be classified as energy saving here in Lesotho? Do you think?
From the sound of the material composition, yes. I would ask, what is the indoor comfort level when he is in the church? If it's achieving, the regular indoor comfort level, and I would say definitely it works. And then I don't know when is the church being built, but if it's an old church, definitely would count as indigenous architectural strategy and passive housing design.
Yeah, it's quite a old church, in the early 1900s, I think, or 80. Yeah.
Yeah, definitely.
So when you speak about thermal comfort, and most of that is based on how a person experienced the space inside, the comfort, as we saw in some of the principles that you discussed. So I just wanted to know, because I had your bio being read and you've been to many places. Where have you been where you found that, some of the most successful passive design principles or strategies were used?
That's a very difficult question, because most of the places I've been to are, let's say, global north places where the majority of the building or housing design are using active strategies.
Oh,
For that, I want to mention some of the places that I've been traveled to. One place that I have a special impression is in Bali, in Indonesia. So the house where I stayed was completely made by bamboo. And I know in that region is very famous to just use materials sold with bamboo. And this is a tricky way to get away from the question, because in that region, besides the rain, it's not much of a heat regulation that you have to control over. But the house was completely built by indigenous material, passive housing strategies. And then I felt completely comfortable to staying there. Actually, globally, the movement towards passive housing is working really well in the Northern Europe, such as Germany, Norway. I think particularly is because they have quite a vast temperature differences, as well as the sun angle differences. So it's important for them to place those principles, such as, control the sun angle between the winter and the summer, where to place windows or skylights to maximize the natural lighting. So those are good examples that I would say.
okay. We look forward to having you in Lesotho so you can experience some of the buildings here, like Pax's house. I think it's a wonderful house. I've been there myself. Still, I think he's probably about to finish it. But can you also maybe unpack a little bit on one of the principles that you talked about, where you were describing thermal bridge, where you talked about it's a path for heat to escape. And um, my question is, why would one want to prevent the heat from escaping? Because I'm thinking from the Lesotho context, in winter you want as much heat as possible, but just from a strategic point of view, yeah, why would one want to prevent it?
Okay, so thermal bridge is, maybe this is more towards like a northern context, but in general, if you have a continuous, the same material bridging between two different environments. One is heat and then the other one is cold. Heat normally tries to escape from the indoor to the outside cold environment, because the with heating environment and the air is generally lighter, and then in the case, for example, if you have a patio and then, maybe I'm not explaining so well, because heat is actually easier to escape with the same structure from indoor to the outdoor, where you are breaking it so that you can control the heat maintained within house, and then separating the two environments. They actually does the opposite than what you said.
Ah, okay.
So the heat is generally
Okay.
trying to escape from the warm environment to the cold environment.
Okay. No, that makes sense. Teddy, are there any questions coming from your side or Facebook on Zoom as well that you can read
Thank you.
to Lulu?
Thank you very much, Reds. Yes, we have one question from Paul Juana. He's asking if suspended timber floor can also be considered as part of the energy saving design.
As just using timber itself, yes, but you probably would have other buildups, and then it would depend on what are the other buildups that you're using to compose the entire floor to evaluate whether it's sustainable or not. But if you're just using, also can I ask where is the location of the climate? Because that will also decide, what sort of buildup will you be using and what sort of a property will you be having in terms of the floor. But in general, timber as a material, yes, it is sustainable.
Okay, thank you. Over to you, Reds.
Okay, since we're talking about material, maybe we can talk about that a little bit. I noted here that when you're talking about overheating, can you discuss a bit further about the physical features or materiality of the structure in terms of like the composition of materials, like maybe timber with I don't know, glass, and this works well in achieving a high kind of thermal comfort. I know maybe it it would be technical asking about you and our values, but just the composition. Is there maybe a way that one can think about it that way in terms of materials?
You mean the best composition using timber as the buildup to achieve the best
Not
insulation?
necessarily timber, but a set of materials that one can use together to for collective thermal comfort.
Okay, so this is getting a little bit technical.
Yeah, okay.
I would say, for example, I was studying rammed earth for one of the project, and rather than purely using rammed earth such as the ancient days, the new project we were researching about achieves a better insulation property by actually placing either an air gap between two layers of rammed earth, or you add another layer of insulation within the rammed earth layers. So this way you sandwich two techniques, the modern one as well as the indigenous one, together to place in area that definitely doubled up the quality of insulation. And I think in the case of stone, for example, in the case study that I put, the stone wall was facing on the north side, but they also have an inner layer and a air gap in between. So the stone receives all of the heat from the south-facing glazing facade, stores the heat, release it out to the indoor environment. So in general, I would say the answer would be a combination of the modern technology in terms of wall buildups with insulation or air gap with indigenous materials that could achieve like really good quality of insulation property.
Okay, okay. No, thank you for that. As because here in Lesotho we tend to, turn to just concrete block. We don't have very much what differences in our buildings is concrete block is single glazed windows, and I just wanted to know a little bit about uh, how one can achieve that high thermal comfort. And so we have a question here from Molope. He's asking about the consideration on fire hazards of these materials. Fire hazards, as they are, they have very low fire resistance. So how do you approach that kind of a scenario?
That's a really, really good question. So I don't know about Pax housing, and I hope he's considering something especially for the roof. But in general, for example, in any of the modern examples that we showed, the inner layer is probably painted with a component of fire retardant material or fire resistant material for the indoor. And probably the outside is stay as what it is, but because it's earth, so it actually has a lower rate of achieving, catch on fire. In terms of roofing materials, typically the strategy, as far as I know, would be spraying or using a layer within the indoor environment to block the fire or the smoke, whereas leaving insulation layers as its own and the exterior layers. That's a really good question. I think a lot of the research also needs to catch on when they're studying the best usage of indigenous materials.
Okay, now that's very insightful in terms of it's kind of like treating the material from the interior side for it to uh, be resistant. Do you have maybe any sources or sites where we can find some information about building energy efficient, I mean, designing energy efficient buildings that you can share that we can send the link here or attach um, in the webinar when we post it on YouTube?
Yeah, definitely. I will create a list of websites where generally you can find a lot of good resources, and then later on you can post it. I actually have a question. So, for example, I'm looking forward to see Pax House, and I really can't wait. What is your impression, and how do you think you, as an architect, can take in and take away from his house in terms of implementing in the Lesotho environment?
From my experience and going to Pax's house, um, the biggest influence I think it's a mindset change to young architects or young people to start appreciating indigenous or vernacular methods of doing architecture, because like earlier I had said that we have that perception of it not being maybe modern or contemporary. So for Pax to take initiative to do that, and he's doing something different. It's not completely round. It's has a different design in terms of the roof. I believe he's gonna have some solar panels there as well to harness energy. So for me, it was really about that um, mindset and just trying to push the fabric of how we can express ourselves as architects in terms of indigenous materials. Yeah. So yeah, I think when you hear, you can see his house is very experimental. He tries stuff, he removes them, and I think it's a wonderful initiative or process. Yeah.
And how do you think the general public sees it and perceives it?
I wonder. I don't really have an answer for that. But from every one of us who has gone there, it was always just been an eye opener. Like, oh, okay. I think it can be an eye opener in terms of you really liking it, or you thinking, what is he doing? This is not how we do things. So yeah, at the very least, it'll make people curious to want to ask, what is that building method, or what is he doing over there? Yeah. Um, yeah, so we have another question here in the chat box that says, can passive design be achieved using non indigenous materials, like modern materials?
Yeah, definitely. So for example, orientation, you can do. You can study the orientation based on where you are, Northern Hemisphere or Southern Hemisphere, with the long facade facing north or south, 30 degrees east to west. Then you can definitely create a concealed airtight environment. You should place your window where would allow passive ventilation to happen by study the data of the dominant wind direction. With that, it's also very important to compare the dominant wind direction with the rain season. If the heavy rain happens in the same direction or the same month as the heavy wind, then don't place a window in there, or place smaller windows, or strategically think of a way that would, allow natural ventilation, but not losing too much of heat. And then also the other way, I would say, not using interior material.
But like,
Form.
do you have like, when we talk about indigenous material, we're talking about thatch, like stone, and then earth blocks or something like that. So like, what type of materials are these that are modern, that can be used to achieve passive design?
That are more than what? Sorry, I didn't hear it completely.
Modern,
That are
contemporary.
modern. Okay.
Yeah.
So standard off-the-shelf materials for the walls and floors, in company with those design physical strategies, such as the ones that I mentioned: orientation, openings, airtight. So you don't necessarily really need to use completely indigenous materials, but if you just change a little bit with your design, such as the orientation, the openings, the size of openings, location of openings, that obviously it would help a lot already.
Oh, okay. Yeah, I think the person in the chat wanted to know maybe the actual materials, like not concrete, but I don't know. We don't know what you have maybe there in that part of the world, like actual tangible materials. Yeah.
Well, so typically in the northern atmosphere, that all of the walls are well insulated with different properties, as well as the roof. They're off-the-shelf, products with standard values that we have to match based on where you are. The floors can be concrete, but you also have layers of materials on top of it. And then, sometimes, most of the time, the floor heating is layout within the floor buildup. It's very active design strategies are integrated within Yeah, I don't know if that answers the question.
Okay. Yeah, I hope it does answer the question. Teddy, do you have any more questions? Maybe final questions as we are in the last 10 minutes.
No, Reds, we don't have any questions at the moment. But I'd like to ask for everyone who's joining us right now to kindly just kindly fill up that survey, because we'd highly appreciate your input on this webinar, as well as any kind of topics that you'd like us to discuss on the upcoming webinars that we might have in the future. I've just left the link there in the comment box, as well as on Facebook. So please kindly fill in those. There's no questions right now at the moment. I don't know if you want to wrap it up, maybe ask Lulu any questions that you might have, and then we can wrap it up after that.
Yeah, I think Lulu, my last question would be, do you think it would be useful to try challenge policies or like what design and construction agencies to, have to have a passive design methodology in what they apply in the architecture? Like, do you think it will be useful to ask people in this discipline to start having to do that as by law or something like that? Like your buildings won't be approved if they don't have elements like that.
I think this will be very challenging to do. I think
Yeah.
there is a middle way where you can say, in order to, being approved, you can have a middle ground of at least maybe 40 or 50% or 60% of indigenous material or passive housing strategies. And I think gradually, with real examples of the built environment, as well as data support from research institutions, I think those would raise awarenesses of the companies in the built environment, designers, contractors, but very importantly, the politics, because they're the one who is making the regulations, and they're the one who can actually say yes or no to get approval for build. So perhaps the initial way is to talk to the government with showing them around, really good, well-designed passive housing built example, as well as showing them the data from all of the studies locally as well as in the globe, for them to understand, okay, in order to preserve the limited energy resources, with just a policy change can actually facilitate a lot to get the result. And I think one day potentially it would be, but it takes time and then takes proper strategy.
Okay. No, thank you very much, Lulu, for the answer. Yeah, from my side, I'm really happy we had this conversation on passive design strategies, or how to design with passive design strategies. Thank you. Over to you, Teddy.
Thank you
Teddy?
very much, Reds.
Okay.
Thank you so much. Lulu, thank you so much for joining us today. And I'd like to thank everyone for joining us for today's webinar. And we've come to the very end. Lulu, that was an amazing and insightful presentation. And if you might have missed it, or if you're joining us at the very end, please subscribe to our YouTube channel. That's RISE, Relationship Inspiring Social Enterprise. That's RISE International on YouTube. And you can also like our Facebook page. That's RISE, RISE Int, at RISE Int on Facebook. That's Relationships Inspiring Social Enterprise. Thank you so much for joining us. And I would like us to join us on the next webinar on the 16th of December, where we'll be discussing entrepreneurship and innovation and the challenges that the youth are facing in entrepreneurship with our with our guest, then that will be Lerata Pekane. So do not miss that one. Thank you very much, Reds. Thank you.
Pleasure.
Thank you so much. Thank you, Lulu.
Thank you so much. Thanks for attending.
All right. Thank you so much. All right. Have a fantastic day, everyone. Bye-bye.
Bye.